Well, here goes nothing, and we're going to try to tidy up all the information we've thrown at you with regards to normal distribution and the data that is normally distributed. So the big thing was when we do see this phrase normal distribution, and that's a very special kind of distribution, then that means this curve, this bell-shaped curve that's on our reference sheet, is now fair game. So on this first slide, I want to review all the basic information we hit you with on day one. First and foremost, we said the mean, the median, and the mode are all equal to each other, and they fall right in the middle where the graph is at its tallest point. And we know that there is a great deal of symmetry involved. We know that 50% of the data lies to the left. We know that 50% of the data lies to the right. We also talked about that mean representing the 50th percentile, which means if you score at the mean on this one, you've outscored or outperformed 50% of your competition. And so forth. Now, the other big one, we said how much of the data falls within one standard deviation. Now, of course, that famous phrase within one standard deviation means we're starting at -1 and we're going all the way to +1, one standard deviation either side of the mean. So looking at your chart, it says, well, we've got to find the -1, we've got to find the +1, and we got to add up the 15, the 19.1, the 19.1, and the 15, and we do that and we round, we're going to end up with 68%. The other famous one was the within two standard deviations. So we said, all right, everything in there is 95%, starting at -2, going to +2. So I'm just staying here, grab the 4.4, the 9.2, so on, so on, so on, and add them up all the way till you hit 4.4 on the other side of the curve. And then last but not least, we do have the 99.7%, which includes all the data within 3 standard deviations of the mean. Well, here we've got a real big bear of a question. There's multiple parts to this that all refer to the graph at the top. So we want to take our time and get this labeled correctly. They said there's 500 total juniors at a certain high school that took the ACTs last year, and their scores were normally distributed. That's the key. You got to see this in the question before you can start to use that chart. They got a mean of 24, so I'm going to slap that right in the middle, right there. Remember our notation, that's an X with a bar across the top. And then our standard deviation is 4, so on the high side, we're just going to continuously add 4. So there's my 28, my 32, and then 36 would be 3 standard deviations above. On the south side, I'm going to continuously subtract the 4, so there's 20, there's 16, and there's my 12. The 12 represents 3 standard deviations below the mean. So let's walk through these questions. First of all, what percentage of the scores is between 20 and 28? Now you'll notice the 20's one below, the 28's one above, so I instantly know, without even looking at my chart, I've memorized this one. I'm going to say 68 or 68.2%. The next one, they want to know what percentage is between 16 and 32. Well, the 16's 2 below, 32's 2 above, and again, just by memorization, I know that 95% of the data falls within 2 standard deviations. And then this one gets a little trickier. They said, all right, let's start at 16, which is 2 below, and let's go to 28, which is 1 above. So let's go grab that reference sheet you got. So you see here I imported it, and like I said, the 16 is 2 below. So I want you to see the -2, start there, and the 28 represents 1 above, so find them 1, and I'm going to add up everything starting with the 4.4 up until the 15. So go ahead and add up all those percentages starting with the 4.4 and see what you get. I ended up with 81.8% falls between those two numbers. Alright, I'm going to continue to refer to that chart. We'll slide it down with us as we go. Let's see here. What percentage of scores is less than a score of 12? Now, where does the 12 fall again? Now, remember, the 12 was -3 standard deviations, or 3 below. So what I'm going to do is I'm going to find that -3, and below that is to the left. I tell you what, that's only 0.1%. Not even 1%, 0.1%. Okay. E, what percentage of the scores is greater than 24? Now, where did 24 fall? Well, 24, that was the mean. How much is greater than the mean? Exactly 50%. Okay, now we're going to change our tune from percentage to actually how many juniors. How many of the juniors were between 24 and 28? Let's see, where's the 24? 24 is the mean, 28's 1 above. So first of all, find the percentage first of all. From 24, which is the mean, let me see, I'm going to try to slide that picture down just a whisker here. Let's see if we can slide that down a little bit. Okay. 24 was the mean, so that's your 0, and 28 was 1 above. how much percent do we have? We got about 34.1%. Now, keep in mind, they said there was 500 kids that took this exam at that particular high school. So what I'm going to do is I'm going to say there's 500 kids times 0.341. Don't forget to move the decimal on that percentage. And when I type that in, I ended up with 170.5. If I round up, that's about 171 students that scored between a 24 and a 28. All right, next question up. How many of the juniors scored between a 20 and a 28? Now, refer back to part A up here. We already answered, we said between 20 and 28 was 68%. So I'm just going to say 500 students times 0.682, and that becomes, let's see, 0.682. I got 341 students. Wow, that's a lot. That's a good bulk of them. All right, H. How many juniors scored between a 24 and a 32? All right, now 24 was the mean. That was my 0. Let's see if I can slide that curve all the way down here. Let's see if it'll come all the way down. It's a little hard to read. Let's see if I can slide it over here. All right, let's give it a whirl. 24 was the mean. 32 was 2 standard deviations above. So I'm going to go 19.1 plus 15 plus 9.2 plus 4.4. Add those up. For a percentage, I got 47.7% of the data falls between 24 and 32. And then if I do my 500 times 0.477, I'm going to end up with 238.5, about 239 students. All right, just 2 more little parts to go, so we'll try to do this without the screen getting too chaotic. They want to know how many juniors scored between a 16 and a 20. So let's find those on our chart. 16 was 2 standard deviations below, and the 20 was 1 standard deviation below. If I add up the 4.4 and the 9.2, I get about 13.6%. So I'm going to take my 500 students, I'm going to multiply by 0.136, and what do I get? I ended up with exactly 68 students. Okay, last one here. How many of the juniors scored higher than a 32? Where'd 32 fall? 32 was 2 standard deviations above. A score higher, let's grab the 1.7 and the 0.5, and there's a 0.1 just off the edge of that screen. If I add those up, I'm going to get about 2.3%. So let's do 500. Now, if I move the decimal twice, it's going to be 0.023. And the calculator says that the product of those 2 numbers is about 11.5, so I'm going to round up to 12 students. Now this next question I threw in for a very, very specific reason. As you read what's called the stem of the question, and you're reading everything up here that's above the table, I want you to ask yourself, do you see the words normally distributed at all, anywhere there? Did they ever tell you that the data in this problem is normally distributed? So the question is, do you see normal distribution? Abbreviate there. Hopefully the answer is no. Okay, you don't. So what does that mean? Your reference sheet does you no good. Okay, if no reference sheet. I want to really emphasize this so that we don't get snake bitten on the test here, which means no bell curve. And really put some exclamation marks on that. If they don't tell you the data is normally distributed, no reference sheet, no bell curve. So what do? Well, we do what we did a couple days ago in class. We're going to enter everything into our calculator. Now the number of children here, that's going to go in my L1. And the number of presidents, that's your frequency, so we're going to go in L2. Now what does this table mean? It means, okay, there was exactly 6 presidents who had 0 children. So again, think of the 6 as your frequency. There was 2 different American presidents that had 1 child. There was 8 different presidents that had 2 children, so forth and so forth. So let's get those pumped into L1 and L2. The question says we want to find the mean and the standard deviation. Again, if they don't tell you which of the standard deviations, we're going to find the population standard deviation, not the sample. So let's go ahead, get those in your calculator. Be very self-disciplined here, carry through on this action, and see if we got the same thing. Alright, on my calculator, here's what I ended up. Now don't forget to, once you do your one variable stats, make sure the calculator looks in L1 and L2. Don't leave your L2 blank. How do you know whether you did it right or not? I want you to look at your n value here at the bottom of the screen. If you see an n equals 41, you know you did it correctly. We're going to round to the nearest tenth, so I'm going to say that my mean was 3.6, just looking right there. I'm going to say ignore the sample, go to the population. I'm going to say my standard deviation was 2.9. See, you would have got a different answer rounding to the nearest tenth if you wanted with the sample. You'd have got about 3.0. Now I'm going to throw in a few extra questions before we tackle the last sentence there. I'm going to ask you, what's the interquartile range? Whoops, what did I do here? Okay. All right, what's the interquartile range? Let's see, interquartile range. So what I need you guys to do is to scroll down on that screen and find your Q3, third quartile, and subtract your first quartile, see what you get. I also want you to find the population variance, okay? Take a moment, hit the pause button, see if you remember the sequence of buttons and the process for finding the population variance. And then come on back and hit play, see if we agree. For my quartiles, I had 5 for the third quartile, and I had, let's see, 2. So I did 5 minus 2, which was 3. And then for the population variance, what I did is I hit the VARS button, which is to the left of the clear. I chose statistics, and then I believe it's choice 4, and statistics gives you the lowercase sigma for standard deviation. Don't forget to raise it to the second power. If we round to the nearest tenth, we're going to say 8.6 is the population variance. All right, now the last thing we got to do on this particular problem is we have to answer the last thing they asked for, and that was how many of these presidents fall within 1 standard deviation of the mean. Normally, if it was normally distributed, I could just say, hey, 68% of the presidents do, and I could figure out what 68% of the total here was. Well, it's not that simple because it's not normally distributed. What we want to do is we want to create a number line, and using the information we found earlier. This number line needs to be very clear and concise. We're going to put our mean right in the middle. And then what I'm going to do is I'm going to take the mean and I'm going to add a standard deviation, which gives me, let's see, about 6.5, I believe. And then on the south side here, I'm going to take the mean and I'm going to subtract a standard deviation, which gives me 0.7. Then what I'm going to do is I'm going to go back up to my list. I'm going to see how many of the presidents had between 0.7 children and 6.5 children. And one of the things I tried to emphasize in class is to be, don't be afraid to mark up your sheet here. So I'm going to cross off the 0. That's too small, but I like the 1, I like the 2, I like the 3, I like the 4, I like the 5, I like the 6. But then 7's too big, 8's too big, 10's too big, 15's too big. The temptation is to stop right there and say, you know what? Well, there's 6 presidents. Not really. You need to grab the frequencies that corresponded to those values and add up this list over here. 2 and 8's 10, 23, 26. I think about 31 different presidents had a number of children that fell within 1 standard deviation. All right, let's get back on the horse here with a new problem. And so the amount of time that a teenager plays video games is normally distributed. You can start celebrating right there. Once you see that magical phrase, we say, yes, we can use the reference sheet. Yes, we can use the bell curve. Now, if a teenager plays video games on average of 15 hours, there's your mean. I'm going to put the mean right here. Don't be afraid to mark up this sheet a little bit. If we write on it too much, you know what? We'll print off a new one. We'll get you a fresh, clean one for the next test. And a standard deviation of 3. So I'm just going to start adding. I'm going to say, well, the 1 is 18, the 2 is 21, the 3 is 24. If I start subtracting the 3, that's going to put me at 12, 9, and 6. Okay, what is the probability that a teenager playing video games between 15 and 18? And I can't stress this enough. We've got to figure out where the 15 falls on the chart, where the 18 falls on the chart. I'm going to say that the 15 is my mean. Okay, I'm going to say that the 18 is 1 standard deviation above, so I'm going to say my mean plus a standard deviation. And I'm going to add up the percentages that fall within those two numbers. That's 34.1%. And the question didn't actually ask for percentage, they wanted the probability. So I'm going to say the probability is 0.341 that a student falls between 15 and 18 hours per week playing video games. Just move the decimal place twice to get probability. All right, on this last problem of the night, I'm going to get you started, and I'm going to let you guys finish it off, and you can show me your answer tomorrow when we check the notebooks. Reason to celebrate here, because again, you do see that phrase, normally distributed. So we say, yes, we can use the reference sheet. Yes, we can use the bell curve. And to talk about test scores with a mean of 80. So let's slap that 80 right here in the middle. Standard deviation of 4. So let's start adding. 1 standard deviation above would be 84. 2 would be 88. 3 standard deviations would be 92. That's a good score. On the south side, 1 below would be 76. 2 below would be 72. Whoops, I Wrote that backwards. And then 3 standard deviations below would be 68, a score of 68. Now here's the trick. They want to know what's the probability that a randomly selected score falls between 74 and 82. So what's the big challenge here? Where's your 74? Where's your 82? I don't see them on the chart. Well, they got a little feistier on us. If a full standard deviation is 4 units, then guess what? 1/2 of a standard deviation is then 2 units. So we can kind of fill in the spaces in between. For instance, 0.5. That would be 82 because I added half a standard deviation to the mean. If I subtracted half of a standard deviation, I would end up at 78. If I continued that process, if I started with 76 and subtracted half a standard deviation, that would put me right here with a score of 74. And that matches. So here's the trick. The 74 corresponds to minus 1.5 standard deviations. The 82 corresponds to plus or positive half a standard deviation above the mean. So what I need you guys to do is to start here where the minus 1.5 is, and go until you hit the positive 1/2. And I want you to add up those percentages and then answer the question, what's the probability, not the percentage, that a randomly selected score falls between that range? Good luck. I'll see you tomorrow.